What people don't realize is that the first law of thermodynamics, the law of conservation of energy, is based on instantaneous gravity. In 2017, LIGO-Virgo confirmed that gravity traveled at the maximum speed of light. This conclusion was reached because the spiraling inward of two black holes caused an audible chirp. The accepted theory is that the energy lost was used to create a gravitational wave. However, a gravitational wave exists even if gravity travels at infinity speed. To demonstrate, I'm going to simulate a binary system with two identical objects approaching directly towards each other. I will color coordinate the values so it is easier to keep track. Constants will be green, and changing constants will be yellow. The actual distance d will be blue, and the extra distance due to the velocity of gravity equaling the maximum speed of light will be red. For my two-bodied system, I will have mass A equal to mass B and just shorten it as m. The initial velocity will be 0 for both A and B, and thanks to Mr. Newton, the acceleration for A at any given time will be equal to the negative acceleration of B at that same time. Therefore, the velocity of A at any given time equals the negative velocity of B at that same time. I will define that it takes time, the time it takes light to travel uppercase d plus lowercase d, the object will each travel the distance of lowercase d. The object located at A will visually perceive object B at location B prime. The object location at B will visually perceive object A at location A prime. Newton has established that the velocity of A at any time t is equal to the negative velocity of B at that same time, regardless of the velocity of the gravity. Therefore, the conclusion occurs that each object is traveled one-half the actual distance. Therefore, the collision occurs when each object has traveled one-half the actual distance d, and the potential energy is based solely on the actual distance d between the objects. In conclusion, the potential energy with the velocity of gravity equal to maximum speed of light is the same as the original potential energy with the velocity of gravity equals infinity. Likewise, the change in potential energy with the velocity of gravity equal to the maximum speed of light is also solely dependent on the actual location of the objects. Change in potential energy equals negative universal gravitation times 2m's over the change in distance between the two objects. Unfortunately, the kinetic energy is calculated by the perceived location. When the velocity of gravity is reduced to the maximum speed of light, then A not only visually sees B at location B prime, but also gravitationally perceives B at location B prime. Likewise, B not only visually sees A at location A prime, but also gravitationally perceives A at location A prime. Therefore, when you cross out one of the masses between the equal signs, we have the acceleration of A equal to the universal constant times a mass, all divided by uppercase d plus lowercase d sum squared, which equals the negative acceleration of B. Concluding that the acceleration is the same equation for each object, except the distance between them is d plus d instead of d, making it less than the traditional acceleration based on instantaneous gravity. Since the change in velocity is acceleration times delta v, it is also less than the expected traditional value, so then is the final velocity. And since the change of kinetic energy is dependent on the final velocity, it too is less than the expected traditional value based on instantaneous gravity. So for a two-body system where the masses are the same and the objects are approaching each other, their increase in kinetic energy, which is based on the perceived distance, is less than their decrease of potential energy, which is based on the actual distance. And energy is lost, not converted into a gravitational wave, but actually lost due to the velocity of the gravitational wave being reduced to the maximum speed of light. Now, the original kinetic energy calculations were all done when the perceived location, when the velocity of gravity equals infinity, equals the actual location. Object A gravitationally perceives object B at the actual location, and object B gravitational perceives object A at the actual location. As we're going through the same equations, we can see the acceleration of A is equal to the negative acceleration of B, which is the gravitational constant times mass divided by the distance squared, and again for the final velocity, and finally for the change in kinetic energy. This is the basis of the 1850 first law of thermodynamics, the conservation of energy, that both potential and kinetic energies were based on the objects perceiving each other at their actual locations. In 2017, LIGO-Virgo confirmed that the gravity wave traveled at the maximum speed of light, and the first law of thermodynamics was demoted from a law to an approximation of conservation of energy, and is valid when V over C all squared is less than 1 over 1,000 based on Jupiter. So when you go through the calculations, you can use the first law of thermodynamics, the approximation of conservation of energy, when the velocity of an object is under 3.16% the maximum speed of light. Now let's look at the orbiting binary systems. Again, for simplicity, we'll declare all equal masses and the velocity adjusted for circular orbit. When the velocity of gravity is instantaneous and the force is perpendicular to the velocity, the system is stable, orbiting in a perpetual circle. Realistically, there may be some decay due to mass transfer, transfer to rotational energy, or radiant energy. But with black holes, the only mass available for these transfers is the accretion disk, and once they pass within the event horizon, there is no mass left for energy transfer. However, if we decrease the velocity of gravity to the maximum speed of light, then the force of attraction is now towards a previous location for each of A and B, causing the angle between the velocity and the force to be less than 90 degrees. This causes orbital decay until the objects reach the periapsis, which will never be reached because the focus of the force vector isn't a fixed point, but constantly points to an obsolete location on the other until they collide. As you can see, the energy is not converted into a gravity wave, but rather the slowing of the gravity wave causes an actual loss of energy, thus devoting the conservation of energy into approximation, provided that the velocities are less than 3% the maximum speed of light. So let's summarize. Between 1609 and 1619, Kepler came up with his 3 laws of planetary motion. Almost 70 years later, Newton came out with his law of universal gravitation, demoting Kepler's law into Kepler's approximation. Back in 9-day, the Kepler equations were acceptable for any minor mass who swept away all of the objects in its orbit, orbiting a primary mass that was much greater than the secondary mass. If we consider Jupiter as the limit for the solar system, and since the mass of the Sun is 1,047 times the mass of Jupiter, then a more precise definition would be that Kepler's approximation is valid in a two-body system where the primary mass is greater than 1,000 times the secondary mass. In 1850, William Rank coined the term law of conservation of energy. In 1905, Einstein's theory, they figured out not to call things laws anymore, of special relativity coined the term fabric of space-time, where time is dependent on speed. Because when velocity isn't squared, it doesn't matter. Because when velocity is squared, it doesn't matter which direction what the direction vector is. This demoted Newton's law into Newton's approximation of non-relativistic gravitation, again applying the 1 to 1,000 rule to the Lorentz time dilation factor. With 1 is no time dilation, with a Lorentz factor of less than 1.001 means Newton's approximation is valid where the velocity is less than 4.47% the maximum speed of light. Finally, in 2017, LIGO-Virgo confirmed that the velocity gravity is the maximum speed of light, demoting the law of conservation of energy into an approximation of conservation of energy. Since kinetic energy is based on the square of the velocity over c, using the 1 to 1,000 rule, this means that the approximation of conservation of energy is valid provided that the velocity of an object is less than 3.14% the maximum speed of light. Further, since each object visually sees and gravitationally perceives all other objects based on previous locations, space-time is not a single fabric, but multiple fabrics, because every object has its own perspective and therefore its own fabric. Unfortunately, to date, this view is unrecognized. Every paper I have read supports the law of conservation of energy and maintains that the gravity loss is transferred into producing a gravity wave. My name is Richard, and this is my defense of my 2019 investigation, showing my assumptions, calculations, and conclusions.